Okay, let's go ahead and keep going. So I'm going to talk about different events that can happen in the terminology. So in probability, we can have or events. It's an outcome is in the event A or B. So if the outcome is in A or is in B, it's or is in both A and B. So what we're going to look at, for example, is let event A equal 1, 2, 3, 4, 5. And B equal 4, 5, 6, 7, 8. So A or B is 1, 2, 3, 4, 5, 6, 7, 8. And notice that I didn't list 4 or 5 twice. I only listed it once, even though it occurred in both sets. Hint, what you want to do is you want to put event A and B together and just remove the duplicates. That's how you do an OR. There's something called an AND event. An outcome is in the event of A and B if the outcome of both A and B occur at the same time. So let's look at the example again, where A is 1, 2, 3, 4, 5, and B is 4, 5, 6, 7, 8. So what number occurs in both? Well, 4 and 5 does. So the hint is for A and B, both numbers have to occur in that. So that would be 4 and 5. All right, complement. Sometimes this throws people, but let's think of this in terms of the complement is the difference than what's in the event. So we note it as A prime. It's A with a little prime symbol at the top, and that means that's not an A. So notice that the probability of event A plus the probability of A, the complement of A equals 1. So for example, let S be 1, 2, 3, 4, 5, 6, and A is 1, 2, 3, 4. Well, what in S is not in A? And that would be 5, 6. So the complement of A is 5 and 6. So remember, event A plus the complement of event A equals 1 because you need to account for everything that's in the sample size. All right, so conditional probability. So the conditional probability of A given B is written of P with A slash B, okay? The probability of A given B is a probability that event A will occur given that a B has already occurred. Okay, so let me say that again. The probability of A given B means that event A is going to occur, but event B has already occurred. So that's how you have to think of it. So a conditional reduction of the sample size. We calculate the probability of A from the reduced sample size B. To formulate the calculation of A given B is A given B equals the probability of A and B over the probability of B where B is not 0. Okay? All right, let's do some of these and I'll give you some examples and we can work on these. Okay, so the sample space is whole numbers starting with 1 and less than 20. All right, so let's think about this. Oops. Let's go ahead and go back up here. So let me make this bigger. So the sample space is going to be, all right, so let me go ahead and do this. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19, and then I'll close it up. Okay, that is all the whole numbers starting at 1 going to 19. All right, so it says let event A equal the even numbers and let event B equal numbers greater than 13. So if I go here and I show you, look, A is all the evens and B is greater than 13. That's all that meant. And look at the terminology. So it says A equals that, B equals that. But in part C, it wants the probability of A and the probability of B. So this is slightly different. So what I did is if you go up and look, okay, so the probability of A is 9. How did I get that? So I counted 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the number of values in A. So and then I'm going to put it over 19. Where's the 19 coming from? It's from all these numbers up here in S. So my probability is 9 over 19. So the probability of the probability of event 6 is 6, which is all the values here over 19. And that's what that question's looking for. All right, so now it's asking for A and B or A or B. All right, so let's look at this. So A and B. So remember, that means the numbers found both in A and B. And if I go back and look, then for A and B, it's 14, 16, and 18. So it's looking for A or B. So it's numbers found in A or B. So if I go back and look, which are found in A or B? All right, so I have 2, 4, 6, 8, 10, 12, 14, 15, 16, 17, 18, 19. Okay, remember, I need to take out the duplicates. All right, don't keep the duplicates in because they don't matter. And remember, I'm not looking for everything in S, which is my sample size. I only want things that are in A or B. All right, the next one wants the probability of A and B and the probability of A or B. Okay, so let's go look at that. So if I go up here and look at A and B, I had 3 numbers that were found in both. And then I just put that over 19, which was the total amount. So the probability of A or B, if I count all the numbers up here, and remember, get rid of the duplicates, it's going to be 12 over 19. The last one asks, what's the complement of A and what's the probability of the complement of A? Okay. So if I look up here, oops, let me scroll up. So the complement of A is everything not in A that is in S. So that gives me 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, all the odd numbers. And to get the probability of that, I do 10 over 19, and that's where I get it. So the next question asks, what is the probability of A and plus the complement of the probability of A? So if I go look here, oops, there it is. The probability of A plus the probability of A complement is 10 plus 19 plus 9 plus 19, 19 over 19, or 1. Remember, that was in the slide previously. That's how you determine what that is. All right, the next one is, what is the probability of A given B? Well, remember that formula. So it's the probability of A and B over the probability of B. So I have 3/19 over 6/19. Okay, remember, when you divide by fractions, all you have to do is flip this number down here. So 3 divided by 19 times 19 over 6. The 19's cross off, so you get 3 over 6. All right, so here we go. Now it wants to know the probability of B given A. And all you have to do then is change the probability on the bottom. So again, probability of A and B is 3 over 19, and the probability of A is 9 over 19. So 3 over 19 times 19 over 9 gives you 3 over 9. The probabilities are not equal for the probability of B given A and the probability of A given B. Okay? So let's look at another example, okay? So here's a table, and I've got males, and I've got females, and I've got right and left-handed, okay? So that's what my table is telling me, all right? So now what it wants you to do is go ahead and do male, female, right, left, male and right, female and left. So go ahead and work those out on your own. And if you see here, I have the answers here that can help you. If you have questions, just let me know.